Hello Kickstarter, my name is Andrew Crouthamel, and take a look at this page. It is 7:19 p.m. on Thursday the 4th, and I haven't even been able to even get home and sit down in time, and we've already blasted past the $4,000 stretch goal. We are well on our way to having an awesome campaign here, so thank you everyone for supporting me and all your great comments. I've messaged every one of you, and we've had some great conversations and some great comments on Reddit and on Kickstarter and all the other locations. So thank you very much for believing in this. So what I'm doing here is we're going to go over some like a basic intro video as to how I do my training and how things are going to look and feel from here. It'll look familiar to some of you who have taken other video trainings, and we're just going to go ahead with just a little demo here of jumping in the beginning of networking. So what we're going to do is hop over to our drawing app, nice handy smooth draw, and we're going to start with the OSI and TCPIP models because that's a favorite for everybody. Before this would have been several videos on what is the basics of networking, where are we going with things, what are the names of different devices that do networking, what is a protocol, what's a port, the real basics of how devices are going to talk to each other from a high level. And now we're going to get into more the technical aspect of things and the details of that. So how we do that is with a layered approach. So you'll have your wire at the bottom there, and your little bits and bytes are going to be moving across. I'm still getting used to my drawing pad here, so please forgive me for some little squigglies. It'll get better. So we'll have our bits and bytes going across, and you'll have a PC here on each end, and then they're going to go and connect into this cable. And then there'll be some sort of human here on this side, and he's going to be sending an email from one side to the other, or browsing the internet, or whatever it might be. And in order to send his traffic from one computer to the other, it has to have some sort of set of rules in order to do that. And we have two models to do so. We have the older TCPIP model, and we have the newer OSI model. So I say that in newer and older, but really they're both relatively old. But the OSI came just a little bit afterwards of TCPIP. So we have our two models, TCPIP and OSI. So you'll say, okay, what is OSI? That's just a made-up acronym. The OSI is actually the International Organization for Standardization, the ISO group, if you might have seen. They have a ton of stuff out there. They standardize pretty much everything. And it just so happened that many years ago, they created a standard for how devices will communicate to each other, right around the time period, a little bit after the TCP/IP model. So how these devices communicate to each other is through this logical breakdown between these two models of what device talks at the bottom of the model, what devices and applications talk at the upper end of the model, and what we have are a bunch of layers. As you work your way from one computer to the other, you're going to be communicating up and down a stack of layers. And the data that's being transmitted and received from one computer to the other is going to go through the layers one direction and up the layers the other direction. We'll clear that up a little bit. So focusing on the OSI model, which is what most people use. Pretty much everything now uses OSI, and everyone refers to OSI, even though when we use TCP/IP to communicate across a modern network, we use OSI from a logical perspective, and some of those layers have been merged with TCP/IP. So there are 7 layers. Let me change our color so it looks a little bit different here. We have 7 layers of the OSI model. We have, get these guys in here, 7 layers. We have our application layer. We have a presentation layer, which doesn't get a lot of love. We have a session layer. We have a transport layer, which does get a lot of love, which you'll find out a little bit later. We have a network layer, which also gets a lot of attention, and our data link, and our physical layer. And I wrote it this way so that it makes a little bit more sense from the wire being at the bottom of our drawing, in that the physical layer is your physical cabling. That's your copper connection, that's your fiber optics, that's your wireless radio beacon. That's your physical layer. How these communications happen from one point to another in some sort of pattern, some sort of encoding pattern. There's some rules there. Each one of these layers has its own rules, and they can talk to each other and pass information up and down these layers with their own sets of rules. And so every layer, even the physical one, has, well, how do I talk on this medium? Which is, it's a great way of breaking things up this way, so that the applications don't have to worry about your physical layer. Why would we want our application to know about the first physical layer? Every application would be huge and very complicated and very bug-ridden. So it's best to separate things out. So down on our physical layer, we have, what kind of media is this? And this is handled by our network card. So is data link, which we'll get to in a second. The physical layer goes through and says, here I'm currently connected to a 100 megabit copper Ethernet connection, and here's how we're going to communicate over that. Here's the rules for it. I'm allowed to do full duplex. We've negotiated that with the other device. Here's how I'm going to communicate, and I'm going to take that data from up the stack, up here, and I'm going to send it out on the wire using these rules that I have embedded in me. We also have the data link layer, which each network card, each port, you could say, let's draw a little port on our PCs here. If we had our little port, and then you got your little cable connected in there. Each one of these is going to have its own MAC address, its own stamped in, people call it burned in address that defines that device as a unique number. And we'll get into more detail about how that works now. But the data link layer allows it to define who is on the other side of the wire, is the best way to say it. So if you have a single point-to-point connection, one device to one device, that's very easy to define who's on the other side. If you're in an Ethernet network, like a lot of us have, you can have hundreds or thousands of devices on the same, essentially same physical link, depending on how you have things designed. And you need to have a way of easily saying, this packet up here in my application needs to go over to this guy, but I don't know where to send it to. So we have a series of ways of determining, well, what is this? We'll use another color. What is this guy's MAC address? What is his defining address, so that I know to send it to him over this physical link? It also has a series of rules, so just like the other layers, that define how do I determine these addresses, how do I pass that up and down to the other layers. And we'll get more in depth with the data link layer and its little sub layers and everything like that later on. So above that we have our network layer, which is where our IP addresses reside. So data link layer is tied in with the physical layer in that these two are basically your physical. It's a terrible color. I chose like a dirty golden color. We'll use blue. These two layers are basically like your physical connections. They're your local connections, more or less, things that are nearby. Your network layer starts to get more logical, you could say. So what you do on the network layer is define some sort of additional protocol where you can provide an additional, hopefully, unique number to everything on your network, and all of those devices will then communicate to each other with that unique number and then pass that up and down their stack just like all the other layers. But it won't be limited to just who's nearby on my physical connection. It's going to be from a larger perspective. So if we have we'll draw a nice little cloud over here. If we have our internet, and then we have, let's say, some sort of campus. This is the North Campus. And then we have the South Campus. We can have these devices talk to each other. We can have these devices talk to each other and know that this guy over here has, here's his little device, this guy here has an IP address of, say, this. And we'll get more into what the IP addresses are. And then this guy over here has an IP address of, and then this guy over here has an IP address of, and they can all be different. And we can have rules within the network layer to define how these guys talk to each other. And then we can also have them in the same subnet, which we'll get into. And then we can also say, well, this guy over here is on the same subnet as this guy, and he can talk to him easily through this link. But then he can also, through another series of rules, talk to this guy, and then through another series of rules, talk to this guy. So the IP address on the network layer, or the IPX address, or the AppleTalk address, if you want to go back many years, allows you to logically give everything a unique identifier, which then allows them to communicate over larger aspects, larger areas. And you can break it up into a more logical progression than you can with your data link layer. You can't really easily define that. In our next layer up, we have our transport layer. This is where we start to meet the applications in a way. So I'll still call this, our transport layer still. Basically, transport layer, when you have applications running up here on a PC, you'll have, Internet Explorer or something like that. And you try to go to Google. This window, this Internet Explorer window, is going to open a port, and then it is also going to try to communicate to Google at a port. And a port really is a number, and there's a whole slew of ports out there that are maintained by IANA, and we'll go into more of that as well, and I'll show you how to get to that list and what they all mean, and some common ones and all the different rules on your ports. But just for basic standard sake is, when we're talking to Google, we're going to be talking on port 80. And then my window here is actually going to have its own port number, and that could be anything. That could be up in the thousands or something. It could be, 1002 or 20,002, something like that. When this application talks to Google on his port, when we send that information through the network, it's going to reference that, so that when Google sends the information back to us, back up our stack, our computer then knows, oh, okay, this data actually goes into this window. And it's a very slick system. And each window that you have, each application is going to have its own unique port, hopefully. So then as the data comes in the network card down here, at the physical side, as it makes its way up the layers, it's going to make sense to the computer, and he's going to figure out, all right, well, which application do I send this to? So that's what our transport layer does. It handles that connection. The session presentation application layers, they are basically your programs, and usually they're kind of all bundled up into one. You don't often have like a separate service running for your session layer or your presentation layer or something like that. It depends on what you're using, but for argument's sake, they're basically one. So we'll call that our application layer. And the session and presentation layers are, we'll get more into detail with those as well, but they basically define how do I bring up and down the session layer. Will determine how do I bring up and down this connection. How do I initiate this and tear it down. The presentation layer will say, okay, well now this data has made it all the way up to me, and now how do I pass it to the application? And there's a set of rules of how do we then communicate and interact with your network drivers. How do I pass it down that stack to send it to somebody and receive it? And then the application layer is our program, whatever we might be using, and that's basically, you know, this application here, Firefox, Internet Explorer, you know, your file sharing application, whatever it might be. One thing you'll notice over here on the left side, I was trying to go along with these with the TCPIP, and I'll fix my names here because I just kind of went off on a little tangent. But TCPIP has its own names for these layers, and that's what I was getting at here. We have the inner network layer and network interface. And in regards to the OSI layer and the TCPIP layer, they both cover the same ground. They both have the same rules basically, but the TCPIP layer bundles the OSI layers, the OSI models layers into smaller groups. So these two share. Internetwork has its own, transport has its own, and then the upper three layers of the OSI model, they share the application name. So that's what I was getting at on the left side, is how the two match and compare to each other. So each, getting pretty junked up here, but each, let me change our brush size, try and clean this up. As these devices talk to each other, they need to break up their communications into chunks. So one thing with our models is all these layers are great and all these rules are great, but they apply it to chunks of data. And these chunks of data are called PDUs. Now, most people don't call it that. Cisco likes to call it that. Technical documentation likes to call it that. Most people during their average day is not going to say, oh, hey, did you check out that PDU? They're going to say, hey, did you check out that packet or something like that, or frame. Your PDU is a protocol data unit. So write that out for you. Protocol. And basically that's the name for a piece of data as it makes its way through your network. So when it's up at the application layer, that's called your data. As it makes its way down to the transport layer, it's going to get segmented up into pieces, and that's going to be called, guess what? A segment. We get down to the network layer, down here towards layer 3, as it makes its way down, it's going to get broken up even more. It's going to be called a packet. And then as we make it down farther to the data link layer, it's going to be called a frame. And then below that we're going to have our physical layer, which are actually our bits, the actual little pieces that go on and off on our wire. So as you go farther down, the pieces get a little bit larger technically, but you could say smaller and smaller, just from keeping your idea of breaking it into pieces. So what we do is we have a chunk of data, and I'll draw that at the bottom here. And we'll go into more detail on this as well when we get into layers 1 and 2 and things like that. But we have a chunk of data, and say this is from our application. So this is a file, cool stuff, .exe, whatever it might be. Cool stuff.exe needs to be broken up because it's very large. This thing is, 100 megabytes. that needs to get broken up into smaller pieces because we can't just send a big chunk across our network. So what we're going to do is slice it up. Each one of these slices is our segment. So that's how we're making our way down our layers now. Each one of those is a segment. So then if we take a look at one of these segments, we'll clear off our space as well. If we expand one of our segments, that was terrible. We're then going to send it down to layer 3, and it's going to get some information attached to it. And then he's going to send it down to, and in there is going to be your IP information. And we're going to go into more detail on this, so you don't have to go crazy. And then in that, as it goes down the layers, it's going to get some more information. It's going to get its MAC information that's in there. And then a little frame check and stuff like that at the end, CRCs. And then it's going to make it down to layer 1, and then it's going to take this whole thing, slice it up into bits, and send it across your medium. So then that's going to get turned into whatever that might be. And then sent across the wire, and then it gets received by the network card over here, and then he's going to take this and in reverse, rip off the pieces, take this segment, and then reassemble it up here. And then collect segment after segment and reassemble it into a nice application data chunk. So that's how things work, and that's where these models are coming into play in how do we nicely interop with each other. Because you can then take these rules of how do I communicate on layer 3, on the network layer, and we can swap that out with other protocols. We don't have to talk IP. We can talk IPX. We can talk AppleTalk. We can talk Token Ring. We can talk whatever you want. You can swap out your network layer, and you can choose whatever protocol you want. You can swap out a bunch of the layers. Back when Novell was really owning the network scheme, they used IPX, and if you go look into the history of that, they had their own stack and they had their own rules. So it's meant to easily swap things in and out, because every time you have an operating system upgrade, every time you have an application upgrade, you don't want to have to completely rewrite or upgrade all of your computers and all of your networking equipment, everything like that. That would be a nightmare. So this is meant to be very modular with this layer system. So that's just a little snippet of one of the training videos. I've glossed over a lot of things. I just kind of winged it right now because I don't have everything put together. But I hope that gives you guys an idea. What we can also do is, when I have some sort of device to talk to telnet into, we can go work on a router or something like that. I can do the little split screen thing, which Windows 7 lets us do nicely. And then we can go browse around, and I can show you interesting things on the IETF website, the IANA website, whatever resources I find for you, RFC information, I can bring that up and share that with you all. So hopefully this is a good format for you. Please give me comments on the Kickstarter, and we'll adjust this as necessary. And hopefully you enjoyed it and you got a good taste of how things are to be. So thank you very much, and I appreciate all the backers. And let's get going on the stretch goals. Let's keep doing some more certifications and some more training videos out there. Thank you very much.